Thank you. So as you can see, yeah, I'm Martin Gregg, and during this presentation, I'll give a high-level overview of the decommissioning projects and progress that's been going on at Hunterston A site, which is run by Magnox. So over the next 20 minutes or so, I'll start off with just an overview of where the site is, the journey it's gone through to get where it's going now, and how the company and site's organised. I'll then move on to some of the main areas of project work going on. So talking about the work that's going on in the ponds area, the wet intermediate level waste, the solid intermediate level waste projects, and then we'll finish up with more conventional plant and structure type projects. So just in terms of the history of the site then, well, construction actually began in 1957, and we were up and generating by 1964, as you can see there. So we were a twin reactor gas-cooled site, one of the Magnox ones, and quite uniquely, we were actually fueled from the bottom. I think we're the only one that's designed that way. We were Scotland's first civil nuclear power station, and when we opened, we were the largest in the world. So we had a capacity of 360 megawatts electric, which was generated from eight steam raising units and 6 turbine generators. And over that operational period, you can see there we generated 73 terawatt hours of electricity. But by 1990, we'd entered the defueling stage, which went on for 5 years. And then in 1996, we're into the phase of the site life cycle that we're in now in decommissioning. So you can see some of the picture there. We had some big visible progress early on in the progress. That's them knocking down the ILW store, but we kind of moved on to some of the ILW projects being more of a focus now. So the site now employs around about 225 full-time equivalents, and the goals really are getting us towards that stage of care and maintenance that you can see in the bottom right-hand corner. So we're aiming for 2024 to achieve that. And what we're trying to do to get there is get all of our waste packaged so it's passively safe and ready for disposal. And the idea is then we make those 225 people largely redundant, and we'd only have a small security presence left on site and a central team that goes around doing periodic inspections and monitoring of equipment. That stage of care and maintenance is then actually the longest stage of the site's life cycle. So the plan would be then come 2080, another team of people come along and undertake final site clearance that gets us back to a greenfield site. So just a bit about how the company's structured then. Magnox, we're one of the NDA's site license companies. So the NDA acts as our strategic authority and makes sure we're spending the government's money in line with their strategy and allocate it between us and their other site license companies. We've got a parent body organisation that have got the contract to manage and provide management guidance for us. It's quite well publicised that that's going to be coming to an end next year, so we're not sure what the relationships there will look like in the future. But Magnox itself, we're comprised of 12 sites which formerly made up the Magnox North, Magnox South and Research Sites Restoration Limited sites. So quite geographically diverse. We're spread all over the country. But 11 of our 12 sites are now defueled, so we're very much a decommissioning focused type of organisation. So even though we've got different types of plants and some different histories, we're all very much trying to achieve the same thing now. And as I said, the focus really now is on our ILW type projects. So I expect most of you would know the UK government strategy for our intermediate level waste is geological disposal. So when the GDF becomes available, it would take packages and put them deep underground for disposal. And now there's this Scottish government policy is for waste to be stored near site and near surface, or disposed of near site and near surface where it's generated. So what in reality that means for us is, even though we're not planning on sending our packages to the GDF, we still have to meet all the requirements for waste packages and acceptance criteria as if we were going to do that. So just some high level facts then before we go into some of the more detailed bits about the project. Well, when we talk about care and maintenance, we're aiming for what we call a 5-box model. So everything apart from 5 buildings would have been deplanted and demolished. Those 5 buildings being the 2 reactor buildings, our intermediate level waste store, the ponds building, and our solid bunkers, which though they would be empty, would be left up and cladded. In terms of the solid intermediate level waste projects, we've had 5 bunkers full of that with 2,200 metres cubed of waste inside, so that was the biggest holding of a Magnox site. In terms of wet intermediate level waste, 180 metres cubed of sludge, 11 metres cubed of resins, and quite a unique waste stream in Magnox, which is 141 metres cubed of contaminated acids. We've got an intermediate level waste store that's now in service. Our ponds was also the largest in Magnox, so an internal volume of 6,700 metres cubed. And the reactor buildings, of the 16 boilers, they've all been delagged, and we've got interim weather protection in place around the reactor buildings, we'll talk about a bit later as well. So talking about the ponds then, you've got a kind of a 6-stage process is the work that's been going on there. So the picture in the top right hand side of the screen, you can see the pond before we started really decommissioning. So the first step was to remove a lot of those furniture, bits of equipment and skips that were in there. We then moved on to operational sludge retrieval, where the sludge that was in the ponds from operations and generated was pumped across into some sludge retention tanks, and then started on with clean and drain. So the picture in the bottom right hand corner shows the pond team at the time doing what we call walking on water. So we had some plastic pontoons that we put across the surface of the pond, and as we drained it, that gave them access to the walls so could UHP wash them. Once we finally drained all the ponds, the next bit was contaminated concrete removal, and the picture in the bottom left there shows some of the areas where we're doing dry shaving to remove that contaminated concrete, and you can see the grids that are broken down to do that systematically. It's not quite as simple as the steps 1 to 6 it says there. So obviously in the stages of UHP washing and shaving the concrete, we generate more sludges. So we also have decommissioning sludges that kind of feed into that loop to deal with later. But we're now at the stage where we have got sludge removed from the bulk of the pond areas. That's now recently been completed. After that, it's going to be about removing some of the historic ancillary plant and equipment like ventilation systems and things like that that are no longer required, and just protecting the building until final site clearance. So there's a couple of detailed pictures of some of the more recent work that's been going on desludging in the ponds there. The one on the right shows what we call a mini digger, so it's just a remote operated digger piling the sludges up into a pile so it can be removed. So you can see quite simple solutions to problems there. The one on the left then shows some of that sludge being put through a core screen to make sure it's suitable for onward processing. Again, pragmatic solutions to practical problems. You can see it's quite hands-on at times there as well for the photograph on the left. But that's been quite recently some big milestones we've made in that area of work. So we then move on to the wet intermediate level waste projects that deals with some of that sludge. And there's one project that will do the whole life cycle for that, essentially we call it WILREP, Wet ILW Retrievals and Encapsulation Project. And so there's a diagram of it on the right there, and it's quite a large plant split up into separate areas. So we have what we call an inner tent, which is where the retrievals of the sludges take place. So there's 3 underground sludge retention tanks where the sludges have been transferred to, and the picture in the bottom left shows the internal inner containment tent. We have some sludge retrieval equipment there, which is just basically a dredging pump on a deployment arm, which then pumps the sludge out into 3 meter cube stainless steel drums for encapsulation. That encapsulation takes place in an area we call the canyon. So you can see in the blue kind of box gantry there, that's where the bulk of the encapsulation plant is located. So at the minute we're in a resin and sludge retrievals phase. So we're combining the resins and the sludges in a single drum. So after this drums are loaded into the canyon, we have several steps. The first one's the fill station where we fill it with resin and sludge. That is station as well. We then encapsulate the waste. So there's a lost paddle that stays in the drum that's driven by a hydraulic motor, and we have various blended cement powders that we put into the drum to encapsulate that. The next station is called the QA station, so we can test that cement is cured with a penetrometer after an appropriate period of time. It then moves on to a capping station, so any excess volume or voidage inside the 3 meter cube drum we can fill up with a clean cap of grout. And then there's a lidding and swabbing station where we bolt a stainless steel lid onto the drum and swab it and check for no contamination, and we can export it into our cross-site transporter. So this is currently the Critical Path project on site. We're nearing the end of active commissioning, so of a total inventory of around about 300 drums we're expecting. We've done just about 30 now, and we're starting to hand it over to the operational phase. And this is a project I've been managing for the last couple of years. Some stuff that you can't see on the animation there, we obviously have separate resin retrieval equipment, which is exterior to the building and comes in through a pipe bridge. And then once we finish the resin and sludge campaign, we'll move on to an acid phase where we'll encapsulate acid waste, which is again stored elsewhere and be piped into the building. So just some pictures now from all around the building. In the top right, you can see one of the stainless steel drums being exported out of the canyon, and below there's what we call the cross-site transporter, which is a shielded vehicle for moving it around site. In the bottom left, you can see some more of the drums inside the shielded canyon area. So you can see it's an open-topped structure, just with a concrete wall to provide shielding, and some of the processing equipment behind there. That drum is just about ready for export. The other two pictures show some of the challenges that we've been facing during active commissioning. So in the bottom right-hand corner, you can see the inlet to our sludge retrieval pump. We had a lot of debris collecting on that we've had to manage. So you can see there bits of plastic, bits of string, and we had rubber, gaskets, all sorts of kind of Hessian type materials that we've had to manage and clean periodically. And the final picture in the top left shows inside one of the sludge retention tanks. So that's actually zoomed in right on the corner. What we were finding as the level has been going down in the tank, and we've been getting more dense materials building up in the corners, and we've had to make an effort to make sure we wash that down and keep that mobilised and agitated in with the less dense bulk of the tank, so that we don't leave it high and dry and a problem for the future. So that's been another thing that we've been managing and developing additional tooling to deal with. So moving on then to the solids intermediate level waste projects. And you can see a diagram there of what's our solid active waste bunker. So it's an above ground concrete structure, which contains various types of solid waste. So fuel element debris, which is the classic kind of Magnox alloy that's been displittered in the ponds, but also miscellaneous contaminated items, miscellaneous activated components, and graphite sleeves from inside the reactors as well. Now, the concept for us to retrieve this waste is through side entry through the walls of that concrete structure. So the picture on the top of the screen there, you can see some operatives doing what we call preparing for a bunker breakthrough, where they're coring through that concrete wall and getting ready to get an access hole cut into that. And the next slide here shows that waste after that breakthrough has taken place. So we've had a lot of success over the last few years on this Sorber solid active waste building retrieval project. So we've now retrieved more than 60% of the total inventory of that waste, and we filled more than 750 of the 3 meter cube stainless steel boxes. So you can see the waste cascading through the breakthrough opening in the top left hand corner there. Then in the bottom right, we've got a remotely operated Brock robot, which is loading it firstly into smaller skips, which are then transferred in to another area where they're tipped into our stainless steel 3 meter cube boxes. There's then a KUKA robot that levels out the waste inside the box so that you get a better packing factor. That process is repeated obviously until the box is full, and the same KUKA robot then lids and swabs the box to make sure it's ready for export into the same cross-site transporter as we saw earlier. But for the solid waste, that's not the end of the picture. The Sorber retrievals project does just that, retrievals. It still needs to be encapsulated and conditioned ready for disposal, and that's where this next project comes in, which is something we call SILWE, Solid ILW Encapsulation Project. So some pictures of it there, still in the construction phase, but the primary purpose of this project will be, as I said, to encapsulate those boxes that are coming out of the solid active waste bunker having been retrieved. It has some secondary purposes as well, so it will have the functionality to transfer particulate waste between the wet drums and solid boxes if needs be. It can also grout a small number of the drums, which are some of the smaller waste streams we've got on site. It's going to have a remediation cell which lets us clean up any contamination or any other non-conformities on the outside of our drums or boxes. And it can also handle some of our other containment vessels which we can put contaminated packages into. Now, as you can see, and as I said, the project's in the construction phase at the minute. There's some of the larger items, equipment, they're just getting located on site. It's a £70 million design and build contract that's been undertaken by Balfour Beatty, and the construction work we've had it so that the areas outside of our reactor controlled area for construction, which obviously makes the conventional side of moving plant and equipment in and out of the area a lot more straightforward. The idea is once it's then built and commissioned, the boundary of our controlled area comes around to encompass the building, and we can start moving packages in and out of it. Some of the other lessons that we've learned and applied to this project is just off-site testing of all the main mechanical components. So that was undertaken at what we call the integrated test facility that was located in Renfrew near Glasgow Airport. So you can see some pictures there of some of the larger bits of mechanical equipment that are now getting installed inside the building, getting tested off-site, and hopefully we've ironed out most of the kind of commissioning snags and a lot easier to fix off a nuclear license site than they are once they're on there. And then the final piece of the jigsaw for our intermediate level waste is the intermediate level waste store. So our one's been commissioned since 2008. It's got a capacity for up to 2,500 approximately packages, of which we're projecting to use again approximately 1,500. They're stacked up to 7 high in an array positioned with an overhead crane inside a shielded concrete cell. So you can see the picture there during inactive commissioning of 7 of the stainless steel boxes stacked up in one of the rows, and the commissioning team there stood next to it. It's got a design life for up to 100 years. And interestingly, some of the nuclear new build companies are basing their patterns for their ILW store pretty similar to this one. So even though they're not all common within Magnox, Horizon Nuclear Power, for instance, have been on a tour of it recently, and it's due to be pretty closely replicated what their store is going to look like. And then just the final bit then is to talk about the plant and structures type projects. So as I said earlier on, we had quite a lot of visible progress on site early on in the decommissioning phase. So the ILW store you saw is now built on top of where our turbine hall was. And there was other bits of big equipment and machinery deplanted in the early days. We've also, in the picture you can see in the bottom left there, there's the glass wall facing to the reactor buildings. Between 2007 and 2010, they've been replaced with what we call a temporary weather barrier, which is basically a fabric replacement to those glass panels, which were becoming unsafe. So they're now attached to the reactor buildings to keep it dry on the inside, before the final reactor cladding project comes along. But yeah, the focus more recently has switched, as I said, to the ILW type projects. Now, as we're getting closer towards that 2024 date for care and maintenance, we're starting to get moving again on the conventional projects. So a lot of the approach now is looking at what we call risk-based deplanting. So we're looking at what equipment and what structures are safe to be left through care and maintenance for final site clearance, and then trying to assess which ones won't be structurally sound or where the tip materials might degrade and need to be removed now. So that's where a lot of the focus is on in their team. An example is we've recently had it confirmed that the boilers can be left in position safely throughout care and maintenance, whereas again other equipment that might not be as robust can be left there. And the final thing, as I mentioned, is the reactor weather envelope. So we're now getting towards the advanced stages of contract negotiations to select that, and that will be, again, some big visible work that will be going on the skyline at Hunterston. But that concludes the very high-level overview of what's been going on. I'm happy to try and answer any questions if you want to type them in.
Thanks a lot, Martin. So if anyone does have any questions, you can type them into the box on the toolbar that just says questions, and we'll be able to see those, hopefully. Okay, so we've got one that's come through. Can you see that, Martin?
Yeah, so they're still in position essentially where they were. They've not been, so there's some of the Barclay ones that were recently taken off site. They spent a lot of time laid down on their side around site before they're moved, but they're where they were to start with, essentially, Val. The next question, what are the biggest lessons learned that would be available to the new build programme? Well, we had an interesting peer assist, as I said, with Horizon Nuclear Power. He came and spoke to us recently, and one of the things that the ONR are making sure they do is actually process the waste as it's gone along. So I think that's probably a good lesson in terms of the ILW. So there have been a few Magnox sites where we did that. For example, at Dungeness, they dissolved their fuel element debris as they went along, and then obviously you've got a nice operational thing which just kind of ticks along as you generate the waste, and you've not got this big problem or big issue that you've not dealt with before come the end of the site life cycle. So that would be a good program. A good lesson. I mean, also just in general, I think a lot of the decommissioning projects you've seen here and other places, they go for very complex, highly engineered solutions. So it's all about making sure, and they're usually overly complex, and we end up going to some simple solutions to get around problems. So it's just trying not to overcomplicate things where you don't need to. It's just something that we're probably guilty of quite a lot in nuclear. So hopefully that answers your question, Jamie.
Right, any final questions at all? Okay, well, I think we'll wind up here then. If there are any further questions, you can email those either to myself at the email address that you would have signed up with, the webinars at nuclearints.com, and I can pass those on to Martin for you. But, right, well, thank you, everyone, and thanks, Martin.
No, thank you. Thanks for your attention, everyone.